In this video, I'm going to show you 4 examples of how we can go about simplifying algebraic fractions. Now, looking at example 1 here, we have a fraction that doesn't actually involve any algebra at all. We're going to start off with this one because it's going to set the foundation for how we go about simplifying fractions that actually involve algebra. So, looking at this, we have 84 over 70. Our objective here is to re-represent this fraction using the smallest numbers possible. The way in which we're going to do this is we're going to have a look what are the factors of the numerator, so what are the prime factors, I should say, of the numerator, and also the denominator. So starting off, we have 84. What are the factors of 84? Now if we go down, the first factor of 84 is, well, we know 84 is an even number, so it's 2. And what multiplies with 2 to give 84? Well, that's 42. So 2 times 42 is equal to 84. Now going down, what are the factors of 42? And 42 is also even, so it's going to be 2 and 21. What are the factors of 21? Well, that's going to be 3 and 7. Now, going from that, we know that our factors of 84 are going to be 2 times 2 times 3 times 7. Notice how I've drawn this tree diagram to calculate all the smallest or all of the prime factors. Now we're going to do the same for 70. We're going to have a look and we ask ourselves, what are the factors of 70? Now we could go the obvious one and go 7 and 10. But we want to do the smallest first, just so we don't miss them. So we're going to say 70 is an even number, so it will be 2. And then we're going to get 35. Once again, factors of 35 are going to be 5 and then 7. So our factors of 70 are 2, 5, and 7, like so. So 2 times 5 times 7. Alright, now what we need to do is we need to have a look what numbers are common. What numbers are common between the numerator and the denominator? Well, first things first is we see a 2 up in the numerator and we also see a single one down in the denominator. We also see a 7 here and we see a 7 here. Now we do also see a second 2 up in the numerator, but I'm not going to highlight it. Reason being is that we only have a single 2 down in the denominator, so we can only go 1 for 1. We can't go 2 for 1. Alright, now I'm going to rewrite this out, ignoring the numbers that we highlighted. So we're going to get a 2 times 3, and then we're going to get a 5. Simplifying this out, we're going to get 6 over 5. So that would be our answer. The simplification of 84 over 70 is simply 6 over 5. So notice the technique. We break everything down into its prime numbers and then we cancel out like for like. So 2 and 2, 7 and 7, and then we keep the rest. Now, that's example 1. Let's have a look at example 2. A squared over 2a. We're going to do the exact same process that we did before. We're going to break everything up into its factors. So think about it. A squared. What are the factors of a squared? Well, that's going to be a times a. So a squared, a times a. Then we've got down in the denominator 2a. So 2 times a. I get my highlighter and I collect like for like. So we have a single a here and a single a here. I'm going to rewrite the fraction, ignoring what I highlighted. So that's going to become a over 2. Done. So a squared over 2a can be rewritten as a over 2. Example 3. Let's break this up. What are the factors of 6? Well, they're going to be 2 times 3 times x times x times z. Then we have downstairs 3 times z. Getting my highlighter, I identify what is common between the two. And I can see that there's a 3 here, 1 3 here, and then there's a z and a z. Cleaning this up, we have 2 times x all over. And notice I don't have anything left in the denominator anymore, so that's going to simply become all over 1. Because that's all over 1, I don't have to worry about the denominator anymore. And then I'm going to use my algebra to simplify this. So it simply becomes 2x squared. Nothing to it. Now finally we have example 4. So this one's a little bit different. Everything's broken up into its prime factors, but what's slightly different is there's a plus here. Now, you might be really gung-ho and you might see we've got an r over here and we've got an r here, so therefore we can write, let's go s. And if you did that, you would be incorrect. Rather, if we want to simplify this, what we can do is we can break the numerator apart and go r over r plus s over r, and then that would become 1 plus s over r, or we can just simply leave it in its simplest form, r plus s, and that is simply r plus s over r. So with this one, we cannot do any further. So in hindsight, what we set out to do was to learn some techniques of how we can simplify algebraic fractions, and the way in which we do this is we break the numerator and denominator down into their simplest forms, so they're primes, and we stretch out variables, and then we look what's common between numerator and denominator, and then we cancel them out like for like.